Welcome to the DIY Honda Garage channel. DTC, or Diagnostic Trouble Code P0100, indicates a malfunction in the mass airflow (MAF) sensor circuit of the Honda Accord from model years 2017 to 2023. This specific error suggests that the engine's control unit is receiving improper signals from the MAF sensor, which plays a crucial role in measuring the amount of air entering the engine. The MAF sensor is typically located in the air intake system, just after the air filter and before the throttle body. Its location is vital, as it ensures the engine management system can accurately calculate air-fuel ratios for optimal performance. This malfunction can lead to poor engine performance, reduced fuel efficiency, or increased emissions, thus necessitating immediate troubleshooting. The following slides will provide a detailed guide on diagnosing and addressing this issue, based on the specific troubleshooting steps relevant to DTC P0100. DTC P0100 points to a malfunction within the MAF sensor circuit, which is crucial in measuring airflow into the engine. The MAF sensor, or mass airflow sensor, calculates the amount of air entering the intake manifold, enabling the engine control unit, ECU, to adjust fuel injection accordingly for efficient combustion. This ensures optimal engine performance and emission control. The MAF sensor is typically located in the air intake system, positioned after the air filter but before the throttle body. In this location, it can accurately gauge the volume and temperature of the incoming air, which is essential for maintaining the proper air-fuel ratio. Disruptions or failures in the MAF sensor circuit can cause the ECU to miscalculate reactions, leading to performance issues. Understanding these components and their roles is essential for effective troubleshooting. The potential causes of DTC P0100 encompass several areas that may impact the MAF sensor circuit. First, electrical connection issues between the MAF sensor and the engine control module can lead to signal inconsistencies. Poor connections, such as those that are loose or corroded, can interrupt the continuous flow of data necessary for proper engine management. Second, wiring failures, including shorts, opens, or broken wires, can prevent the MAF sensor from sending accurate readings to the ECU. Lastly, a malfunctioned MAF sensor itself is a common culprit and may need replacement if the above checks do not reveal any issues. Identifying the specific cause allows for a more efficient and effective repair, minimizing further complications. Symptoms associated with DTC P0100 can manifest in various ways, directly impacting the vehicle's performance and efficiency. One primary symptom is poor engine performance, which can include rough idling, stalling, or a lack of acceleration. Drivers may also notice an increase in fuel consumption, as the ECU struggles to maintain proper air-fuel ratios due to unreliable data from the MAF sensor. Additionally, the illumination of the check engine light is a common warning that something is amiss. If the check engine light persists, it indicates a more severe underlying issue with the engine management system. Understanding these symptoms helps drivers recognize when to seek diagnostic services, ensuring timely interventions to prevent further problems. The first troubleshooting step involves verifying the problem by turning the vehicle's ignition to the on mode, which powers up the vehicle's electronic systems without starting the engine. Following this, the Diagnostic Trouble Code (DTC) should be cleared using the Honda Diagnostic System (HDS). Clearing the DTC resets any fault codes stored in the engine control unit, ECU, allowing for a fresh diagnosis. After clearing the code, it is crucial to wait at least 2 seconds to ensure the system is fully reset before checking for any pending or confirmed DTCs once again with the HDS. This step ensures that any lingering issues can be accurately assessed and confirmed through the diagnostic tool, setting the stage for further investigation into the problem. In the second step, the ignition should be turned off, ensuring the electronic systems are completely powered down. Next, the MAF sensor IAT sensor 14P connector needs to be carefully disconnected to isolate the sensor from the electrical system. After disconnecting, the vehicle should be turned back to the on mode for testing. Once in this mode, it is essential to measure the voltage between the designated test points located within the MAF IAT sensor connector. Specifically, test point 1 is on terminal number 2, and test point 2 is on terminal number 3 of the connector. This evaluation helps determine whether the expected voltage of approximately 5.0 volts is present, which is vital for the proper functioning of the MAF sensor circuit and illuminates the next steps in the troubleshooting process. Step 3 commences again with the vehicle turned off to ensure safety. The next action involves jumping the SCS line using the Honda Diagnostic System, HDS, which allows for a specific set of diagnostic tests to be run without interference. After the SCS has been jumped for more than 1 minute, the MAF sensor IAT sensor 14P connector should still remain disconnected while the PCM Powertrain Control Module connector E, which contains 80 pins, should be disconnected as well. This allows for a continuity check between the designated test points, specifically between terminal number 3 of the MAF connector and body ground. Assessing continuity in this manner determines if there is a short circuit within the VCC2 wire that connects the PCM to the MAF sensor. Identifying a short signals a need for specific repairs to restore the integrity of the circuit. In the fourth troubleshooting step, the vehicle remains in the off-lock mode, as previous components continue to be evaluated for continuity. The goal is to determine continuity specifically between the testing points identified earlier, terminal number 3 of the MAF IAT sensor connector and pin number 77 of the PCM connector E. This process involves using a multimeter to effectively check for continuity, which confirms whether the VCC2 wire is intact without any faults. If continuity is established, it indicates that the wire has no breaks or opens and that signal flow should be adequate. If no continuity is present, it signals an open circuit in the VCC2 wire that requires repair to ensure accurate signal transmission from the MAF sensor to the PCM. The fifth step of the troubleshooting process requires checking for continuity in another wire, specifically in the SG2 line. The vehicle should still be powered off to allow safe assessment. Similar to the previous continuity checks, the focus is on determining if there is a break or open connection between terminal number 2 of the MAF sensor connector and pin number 78 of the PCM connector E. This examination will reveal if the SG2 wire is operational or if it has issues hindering its performance. Establishing continuity signifies that the wire is functioning correctly, while a lack of continuity means an open exists that needs to be repaired for the system to work correctly, reflecting the importance of ensuring all wiring is secure and intact. In the sixth step, the vehicle remains off initially to ensure a safe environment for the troubleshooting process. Turning the SCS line with the Honda Diagnostic System, HDS, is necessary to prepare the system for the next set of checks. Once the SCS has been jumped and the vehicle has remained in this state for over 1 minute, the MAF sensor, IAT sensor 1 connector, should still be disconnected, along with the PCM connector E. The focus of this test is to check continuity between terminal number 1 of the MAF connector and body ground. If there is continuity here, It indicates that the wire known as the FGP is shorting to ground, requiring immediate attention and repair to restore proper function. No continuity suggests that the FGP wire is intact, allowing the diagnostics to progress to the subsequent steps. The seventh troubleshooting step continues with the need to check for continuity on the FGP line, maintaining the vehicle in the off mode. As before, the test involves assessing continuity between terminal number 1 of the MAF sensor connector and pin number 61 of the PCM connector E. Using a multimeter, technicians can verify whether the circuit between these points is intact. If continuity is confirmed, it signifies that the wiring for the FGP line is functioning properly, suggesting that the issue lies elsewhere within the system. In cases where no continuity is determined, technicians must locate and repair the open within the FGP wire to restore functionality, ensuring all connections are secure and able to transmit data effectively. Step 8 requires the vehicle to be turned to on mode to commence voltage measurement tests on the FGP wire. Testing voltage is critical, and the aim is to measure between terminal number 1 of the MAF sensor connector and body ground within this mode. If voltage is present while disconnected, it indicates a short to power in the FGP wire, necessitating repairs on the connection leading from the PCM to the MAF sensor. Conversely, if no voltage is detected, it indicates that the FGP wire is intact. This voltage check is vital in assessing the health of the wire, as it significantly impacts the overall sensor functionality and accuracy. Accurate diagnostics at this stage can prevent unnecessary replacements and direct focus toward effective repairs. The final troubleshooting step involves testing the MAF sensor IAT sensor 1 for any potential failures that could cause a circuit malfunction. First, ensure the vehicle is turned off, and then substitute the original MAF IAT sensor with a known good component. This step acts as a practical test to determine whether the sensor itself is leading to the DTC P0100 error. After this replacement, it's essential to reconnect all previously disconnected connectors and exit the SCS mode utilizing the HDS. Then, turn the ignition back to the on position and clear any DTCs using the HDS. Following a brief wait of at least 2 seconds, the next step is to check for any pending or confirmed DTCs again. If DTC P0100 still appears, it confirms the need for a new MAF sensor. If the code does not appear, it indicates that the MAF sensor was the original problem, and other checks should be conducted to ensure no further issues are present. Final repair verification is a crucial step post-repair to ensure that the issue has been resolved. First, verify that the new or repaired MAF sensor is functioning correctly by checking it against manufacturer specifications. It is essential to ensure that all connectors have been reattached properly and securely to prevent future disruptions to circuit functionality. Following these checks, clear any DTCs from the vehicle using the HDS once more to reset the system status. After clearing the codes, a test drive should be conducted to monitor the vehicle's performance and check if the DTC reappears. This comprehensive verification process ensures that not only has the immediate issue been addressed, but that the vehicle is operating smoothly without further complications. Preventive maintenance is essential in avoiding issues related to the MAF sensor circuit, including DTC P0100 errors in the future. Routine inspections of the wiring associated with the MAF sensor help identify any fretting, corrosion, or breaks that may not be immediately visible. By proactively checking the health of the MAF sensor, vehicle owners can ensure optimal performance, preferably using certified technicians for sensor servicing. Additionally, it's vital to ensure all electrical connections are secure and free from debris to maintain a consistent signal to the ECU. Implementing this preventive maintenance regime will not only enhance the reliability of the MAF sensor circuit, but also contribute to the overall longevity and performance of the engine system. In summary, understanding DTC P0100, which signifies a malfunction in the MAF sensor circuit, is crucial for effective vehicle diagnostics and repairs. A series of focused troubleshooting steps, including voltage and continuity checks throughout the circuit, help in isolating the exact cause of the issue. Emphasizing the role of the MAF sensor in engine performance highlights the importance of timely repairs and accurate diagnostics. Preventive maintenance measures, such as routine inspections and keeping the wiring system clean and intact, can greatly reduce the chance of recurring DTCs. Through comprehensive understanding and careful adherence to troubleshooting protocols, vehicle owners and technicians can ensure long-term reliability and performance of the Honda Accord's engine system. Please like and subscribe to the channel. See you next time.